Welcome everyone to my another tutorial. This is the first image stitching tutorial. So you already know that Google Photos app has stunning automatic features like video making, panorama stitching, collage making, sorting out images based by persons in the photos, and many others. So have you ever wondered how all these functions work? So I thought, how hard can it be to make panorama stitching on my own by using Python language? So what is image stitching? In simple terms, for an input there should be a group of images. The output is a composite image such that is a culmination of image scenes. At the same time, the logical flow between the images must be presented. For example, think about sea horizon while you are taking new photos of it. From a group of these images, we are essentially creating a single stitched image that explains the full scene in detail. It's quite an interesting algorithm, isn't it? So let's first understand the concept of image stitching. Basically, if you want to capture a big scene and your camera can only provide an image of a specific resolution, and that the resolution is, I don't know, for 600 to 400, it's currently not enough to capture the big panoramic view. So what we can do is to capture multiple images of the entire scene and then put all bits and pieces together into one big image. Such photos of ordered scenes of collections are called panoramas. The entire process of acquiring multiple images and converting them into such panoramic is called an image stitching. And finally, we have one beautiful big and large photograph of the scenic view at the end. So, beginning with the tutorial, firstly let us install OpenCV. So, about OpenCV, you will need a specific version. It's 3.4.2. As I can show you my import CV2, for example, and CV2 version. And actually there is a reason I am using this version for this tutorial. And if you're doing my tutorial, you will need to install this version. Well, if you don't have OpenCV already on your device, it doesn't matter. You will install according to my text tutorial on internet 3.4.2. I'll write everything there. And if you already have OpenCV, you will need to uninstall it and then install my required version. And the reason is that the newest version doesn't allow to use that image stitching functions, so that you'll need to build OpenCV library by yourself with these functions. So, okay, I'll creating a new Python file. So I'll call it main.py, and here I have three images. As you see, there is original image. So it's only a beautiful photo, and here I edited this beautiful photo. That this is the left side of photo and there's a right side of photo. So this means that my original photo was sliced in a way that these both two images would have some kind of overlap region. And okay, I'll close them and I'll begin with my code. I don't need this either. I open it. So let's begin from import our libraries. So it will be CV2 and import numpy snp. So to get a final result, there will be 6 steps. In this tutorial we will do only 3, and then the next tutorial will do also 3 steps. So I think this tutorial will be longer, but who knows, we'll see. So what I'm doing here is we are importing these two images and converting them to a grayscale. So I'm beginning with my code. So image, I'll call it like this, CV2 image read, and image read, and I'll call it left. Okay, like that. And so if you're doing your own tutorial, sometimes you might face that it's taking very long for you to process all this code. This will be at the end when we're really stitching the image, so you will need really good computer to compute everything quite fast. So I recommend you to resize the image for testing purposes, and to get faster results. So to resize, I would recommend you to use following function I'm writing right now. Sorry again. And here will be 0, 0, and here will be fx equal to 1, and here will be fi equal to 1. So this is a function to resize. One is equal that we are not using any resize, and the last is to get our RGB image. So it will be again image like that, and then only the color. This comes some kind of standard image to grayscale. So this way we'll receive it, and I'll comment this right now. I'll leave it for you if you want to check how resize works. And here is another one. I'll remove, and I will call it image 2, and here will be on the right side. Okay, and what we need to do, so we need to find out features matching in both images. We shall be using OpenCV contributions shift operation descriptor. Shift is meaning scale invariant feature transformation. That is a very powerful OpenCV algorithm. You can read more on my website. I'll post all the links to documentation, and you can understand more about this feature. These best matched features act as the basis for stitching. So what we do next, we extract the key points and shift the descriptors for both the images as right now. So shift, we call it like that, equal to CV2 x features 2D shift create function, like that. Here will be find key points doesn't matter, and what we need is key point 1 and descriptor, and the function to get this is shift dot detect and compute equal to image 1, and here I'll just add none, and we copy this line for our another image. This will be called just like that. And what we can do now, we can look how it looks for us. So CV2 image show. So I will show you how our descriptor look like, and I'll call it original image something like that. Original image, left key points, and here is special OpenCV function, draw key points, call it key points, and here is image and key points. So we are drawing key points on our original image. Now, so let's see if everything works. What color, BGR to grayscale? That's a mystery for me. Give me a second to find out what's wrong here. Oh, I see now what I did wrong. So here should be CV2 and here CV2 also. So let's build it. So as you can see in this photo, this is the features our shift function detected. Once you have got descriptors and key points of an image, I mean two images, we will find correspondences between them. So why do we do this? Well, in order to join any two images into a bigger image, we must find overlapping points. These overlapping points will give us an idea of the orientation of the second image, according to the first one. And based on these common points, we get an idea whether the second image is bigger or smaller, or has it been rotated and or overlapped, or maybe scaled down, up, and then fitted. All such information is yielded by establishing correspondences. So this process is called registration. So for matching images, can be used either FLAN or BF matcher methods that are both provided by OpenCV. So now I'll write both examples one by one and we'll get the same results. So both examples matches the features which are more or less similar in both photos. So let's begin. I'll comment this line, we don't need it anymore. So I will begin with simpler way, it's a shorter way. So I'll write just a match is equal to CV2 BF matcher and matches, we call it like that, equal to match dot convolutional network match descriptor 1 descriptor 2 and key equal to 2, just like that. And now we must use filter, but for now I can show you how it would look without any filter. So we need to write some draw parameters. Draw parameters equal to dictionary, like that, and match color equal to O, and here will be 255 and here 0, like that. Single point color equal to none and flags equal to 2. I think that's fine. And now let's show this image for us, and this will be image 3, we'll call it like that, and CV2 draw matches. Right now we'll draw everything on our original images, not grayscale, so it will be image key point 1, the next will be our image, and key point 2, Then we'll go our matches. Then we'll go none and our draw parameters. Just like that. And now let's use CV2 image show or original image draw matches, just like that. And in case we would like to save it, image save will change this, or image write. I think image write is the right way. So here we'll just write image free to show us. Okay, let's see if maybe I wrote something wrong. Match BF matcher. Well, anyway, let's then write our first way, then I'll check our second way. This is the longer situation, and it requires some kind of flan index. Index kd3 equal to 0, and index params, and there will be search params, just like that. So let's begin to this. This will be dictionary and algorithm called like that, and trees equal to 5. Okay, and here will be also dictionary, and inside the dictionary will be checks equal to 50. Okay, and the last is match. So cv2 dot flan based matcher equal to index params and search parameters, just like that. Okay, I'll try to save it. Dicts. Yeah, I wrote it wrong a little. Dictionary. What? Okay, I'll stop the video for a moment. I'll check what is wrong with it. So I came back from paused video. Well, I'm not sure what was wrong. I checked that whole code, but there's nothing wrong here. So let's see how it works. We have here something wrong. Let's check again. Well, I'm not sure what here can be wrong. Well, I'm not sure what's the... Well, actually, what I wanted to do is to show you the everything without filtering data, how it looks with everything as it is on photo. But anyway, let's go back to our filter. So what is here? We have to filter a good and bad matches. So how we do that is that we create a simple array checker for MNN in matches. What we do, if our M distance is smaller than, well, for our photo I'll write like this, but if there will be a little difference, photos, it won't work like that. So you will need to increase this number. I'm writing this because only this quite identical photo, and then there shouldn't be any mismatches. So here I'll just write good, and let's see how it will look for us. I hope. Oh, it's working. So as you can see, there's a left photo and the right photo, and here I wrote 0.3 because not to show you how it looks like. So it found a matches for us in this. So how it will look if we increase this number. For example, 001, there should be much more of this. As you can see, much more of these matches. And if I'll write, for example, 3, there will be even more. So as you can see, we can't even see a photo. So this is the reason I wrote like that. So now let's try again our BF matcher. I'm not sure why it's not working. So as I can see, it works quite different for us. Okay, let's try give it more. As you can see, it works a little different. Or it was only the fake signal. Let's see. Oh no, it worked the same. It just was something wrong with it. So, and if I'll okay, let's run it again for safety reasons. And if I'll uncomment that one, okay, let's save. No, not this. As you can see, it's exactly the same. So it's up to you which we'll use. Well, I'm not sure why it wasn't working before, but at least it works right now. So we have an output image with matches here. So now we should do a homography and stitching. So now in this short tutorial we finished 1 to 3 steps I will write on our web page. What is left to do is that we'll need to find homography between these two images to execute an image transformation. Then we'll be able to proceed image stitching. So I'll do with same image, and then later we can try to do that with different images, so maybe with real photos. So I think that's it for this video. I hope that this was a useful video for you. If you have any questions, be sure to leave them in comment section below this video. And if you liked my video, smash up these likes buttons and subscribe my channel. Then you will get more of these exciting videos. Text version of this tutorial and links will be left in video description. Thank you all for watching. Good luck and see you in a second this tutorial.